to the muffin out.
Alright, so now I will start. Okay, so welcome everybody. I'm so glad at how many people we have here and able to get from all over. You probably know who I am because I've probably emailed a lot of you about everything going on. But you might not know what I do. So I've taught for 11 years. I am no longer teaching full-time, although I do teach robotics to elementary schoolers after school, 3 days a week. Freedom Shores, I heard that name. I'm there.
Oh, you are?
Yeah. So that's a really big change for me. I've always done middle school, high school mostly, so it's different, but you know, I guess I can never escape teaching. So what I'm doing now, I coached an underwater robotics team for a while, and then I went to a workshop about it in Tennessee, and I talked to my husband. I'm like, you know what? I just want to go back to school for this. It'd be fun. And he's like, all right, let's do it. So I am now back in school for electrical engineering, and I'm interning at SiriusXM, and I'm also teaching robotics after school. So that's my life now. Before, I taught coding. I taught AP computer science. I taught beginner level coding. So basically, middle school level up to AP computer science. So the goal of this GeoGebra Python, which just went away on the screen because my thing. So from my understanding, well, this is pretty new for GeoGebra, okay? And it was designed because somebody asked Marcus, and they said, I want to use this to teach students coding. I want to use GeoGebra to teach coding. So he started, I think Mike, I don't know, you guys probably know, but he's the one that kind of heads this project. It is still in beta, so there's a lot of things that are still improving. And actually, when another guy had his details at the end, Ben North, he saw that I was doing this. He's like, hey, I have some ways I can improve this after I saw what you're presenting. So he actually is consistently, improving it based on feedback and what needs to get better, because that's, what we all want, right? And he just noticed some things, some functions that maybe I wanted, and he added them. So if we get to the whole thing, and I just want to be clear, I do not intend to get through everything in this book by the end of today, because who's done coding before in this room? A lot more than I expected, actually. Okay, well, so if you have done coding and everything I do is really easy and you want to go through past what I'm doing, I kind of designed it in a way that you can go forward. Like, I really like to do workshop style things where, you can stay with me, or if you want to move ahead and go at your pace, if you want to go a little slower, you can do that as well, okay? But that's basically what I do. So you can get to this book if you go to bit.ly/PyGGB24. It is case sensitive, so if you put a lowercase p, not going to work. Okay, so I did a capital P, lowercase y, capital GGB24. You can also get to it on the conference page. I linked it at the bottom so you can get there as well. So what is Python or PyGGB? We can get to it from this link here. It is completely web-based, so if you've done Python before, you know that you can download it on a computer and you can import libraries. You can't do that with this, and I've tried it. They have something called GGB, but it's a totally different thing. But this is PyGGB. One thing you'll notice is there's a bunch of code here. It basically loads your most recent code anytime you do it. So this must have been what I was doing before. Don't worry if you don't understand any of it. There is a way, which I'll get to here. Let's go to GeoGebra and Python. If you go to this link here, it's like index and it puts new blank. That will open up a blank one. If you don't want to remember that, you can just say file new, okay? So it just has an option, you can do file new. So if you have something loaded there, don't worry, just press file new. Most of you will have something blank if you went to that web page because you've probably never used GeoGebra Python before. Okay, so this is, yeah.
We're not there.
Do it again.
So here, GeoGebra.org/Python. Sorry, I should have,
Do we have it?
and then this is the one to do new blank, huh?
What we should open that now? We should open GeoGebra.
So this is to the book, so you can have all of the links and you just click on them. Or if you just want to open GeoGebra Python, you go to geogebra.org/Python. I would probably go to the book because there's some activities in there. But if you wanted to just like start a new one,
What is the link to the book? This is on the top, yes?
Yep, this is the book. Anyone need? Yeah.
How can I save my project so I can get back to them later?
So similar to the same way you would save a Word document. So if I go here, there's a Save Now icon. And then if I press Open, there's all of the stuff I've done before.
Okay, so the next time I log on to my GeoGebra, next time I go to this website, and I click on files, it'll be there?
Yep,
Can you show again the link, please?
I can.
Also, this is with the big design and GeoGebra.
Alright.
So, if I go to that link and I click on file, how does the website know who I am?
That is a great
In order
question.
to see my previous files.
That's a great question. I don't know. I will find out. I don't know if it's because I'm logged into GeoGebra or if it's because it's remembering my cookies or something. So I'll have to ask Ben. And I do have Ben's contact information at the end of this. He is extremely responsive and like really excited to share any questions you have. He will respond. Okay. And I asked him. I said, hey, can I share your info? And he's like, yeah, absolutely. So yeah, he is great. But that is like a really good question. I'm really not sure how he does that. All right, so good question so far, and I want to basically go into the first part. So if you've never coded in GeoGebra Python before, like who's done that before? Nobody, right? So there is a way, as we were just like looking at, that you can look at example programs. So if I go here and I go to open, these are all things I made before, right? But does anyone notice something else besides my programs? Examples, right. So there's a bunch of examples that were created by, I think most of them were created by the ones who created this version of the software, where you can see how to do different things using GeoGebra Python. So here, this one's kind of cool, the juggling animation. And then if I hit run, it's going to show what this code over here does. Okay, so you don't need to start from the ground up. And you can actually take this, make your own version of it, and then save that as well. So it's not going to edit theirs, because those are the examples, but you can modify, like, oh, okay, I don't want those balls to be those colors, so let's stop this. Let's find where the balls were. So we have, let's see. This one is a really complicated one. I don't know why I picked this one. Okay, so here's the ball colors. You see that? They're using hex, if you know hex, but whatever. We can pick any number 0 through 9, any letter A through F. So let's just pick some. All right, so let's, here. You cannot edit, make your own copy. Juggling guy, whatever you want to call it. All right, and then now I'm going to change these colors. All right, so let's pick a letter D. P won't work. It's got to be A through F. 3, E, whatever. And then you can change all of them, whatever you want to do. F would be white. I know that. If I want red, RGB would be, wait, F00, right? So you can kind of do whatever you want with those. F0F. I honestly have no idea. Most of these what color is going to show up, so we'll see. All right, now let's see what happens. So now if I run it, all of my balls are different colors. So this is kind of a cool little activity. If I were doing this with students, I probably would have started with a simple model, but before I had them edit the code, this one's kind of complicated, which goes into the next thing I wanted to talk about. How do we teach kids coding? Let's go back to, where's my stick? Accessing sample programs. Okay, so here we go. Learning to code, and I'm not going to have you guys fill this out, we'll just talk about it. Who's taught coding? Okay, strategies to teach kids coding, and if you guys haven't taught it and you think you might know some, what are your thoughts on that?
Well, I usually start with Scratch. Block coding, it's like Lego coding.
Yeah.
Before they start having to write the actual code.
Yes, that is nice. Scratch, because it gives you blocks that you would send Scratch. Do you start with Scratch too?
So I was thinking code.org.
Oh, I love code.org, yeah. which I have done too. So, yeah, ignore that. Sorry. You guys should share your IDs in the link, but since we're all in one room, whatever. So, yeah, I would agree. So code.org has a lot of activities to kind of help you if it's your first time coding. They will do beginner levels, then they have the AP courses and everything else. So it's a really good example. One thing which I think it goes through to when I taught math as well is scaffolding. We all know what scaffolding is? Right. So we don't start with the hardest thing like I just did. I shouldn't have done that. Okay? We start with something simple. Okay? Like how do I make a point? Or how do I make a segment? All right? And then once they do that, we're like, okay, we've made a segment, or here, this one I had to make a square. What do we do? How can we make this process easier? And things like that. So now we've made a square. Now we've repeated 3 actions. Maybe we can add something to make it repeat. And then after that, maybe we can add a function, so that way we can do it anytime we want. So I always like to start with that, and that's kind of what I used to do when I did my first project with my beginner level students, starting with the basics and then building on it each time, right? So we're kind of going to do that here. So if you guys aren't already in this, you can go to geogebra.org/Python, or you can go to the book and go to this page. The first 2 things I want to show you is how to get Python, or how to get GeoGebra into this, because you would think it's by default, but it's not. So you have to first start by typing import GGB. That's basically telling the program, I want to use the GGB library in my Python.
Are you using this new one?
Yeah, that's a blank one, but you can either do it into where I have it, or you can create your own, it doesn't matter.
Oh, it's okay.
Yeah, so I'm typing import GGB. So that tells it that I am now using GeoGebra. Cool. The next thing, I like to do this because whenever you have a library in Python, how do I know what commands it uses? It's not obvious. You can guess, but if you really want to know, there's a way to do that. Print dir GGB. And then, now I'm going to run this, and you'll see at the bottom it has, it's a little hard to read here, but you can see it's got all of the commands that are options. So Boolean, circle, clear console. Everyone see that? I'm talking about here. And this tells me basically all of the options I have for commands. The ones that we're going to use here are going to be segment and point, probably. Let me see. There's point. That's a really big one. And then segment. So let's start with making a segment. So our goal here, so if you want to go ahead of me, that's fine. If not, you can do it with me. Okay, our goal here, and I'm actually going to open up a blank one because this one's kind of hard to see for you guys. So I'm going to do a new blank project, right? All right. I'm going to start with making a point, okay? So point, let me call it A. So in Python, which is why it's one of my favorite starter languages, you don't have to declare things like you have to do another language. And I can just say A equals. I don't need to say if it's a point, segment, line, where it's JavaScript or other languages you do. So I'm just going to say A equals point. And then I want to say what the coordinates of those points are. So I'm going to put a point at 0, 0. Now run the code again. Yay, there's a point now at 0, 0. All right. Anyone have any ideas how I could create a square?
Next line.
4 points, right? That's how we would start. So let's see, where's our next point going to go? 4, 0. Okay, good. And then let's just go ahead and make all 4 points. All right, let's run this. Awesome, we have 4 points. Wait, is that a square? Yeah, that's just 4 points. So how do we now take these and make a square?
Or square.
segment, or, so there's two options. We can do segment, or there's another tool here, polygon. So now, let's try this, all right? Polygon, A, B, C, D. I'm not sure if this is gonna work. I think I need to put it into a list, but let's see. Yeah, so it doesn't like that. It's saying basically, you need to, it must be either interval of points, point, number of sides. I don't know if I like that error message because it's not that clear to me. I know that I have to put this into a list, which is why it didn't work. In Python, you use square brackets to create a list.
In GeoGebra or square bracket?
Yeah. Well, in Python, because in GeoGebra, actually, no, it's different. So this is basically as if we're not using the software, GeoGebra software at all. It's Python GeoGebra. So the rules that we normally use are not actually the same. Like normally, if you guys made a list in GeoGebra, you use the curly brackets. We don't do that here. We have to use the Python rules, not the GeoGebra rules. Yeah?
If you don't put the points in like a nice order, it makes an hourglass.
Yes, it does. Anyone else have that happen? So if we did this instead, watch what happens. So she switched those 2 points, right? Yeah. So this is actually something your students will probably do too. So that's a good teaching moment because you're not only teaching a coding concept, now you're teaching also a geometry concept. How do you name a polygon? Right? It's always in, you have to go in counterclockwise order. So if they're not doing that, I'm like, well, why would you put that letter in the middle? It's the program's only doing what you told it to do. Okay? I always tell kids this when I'm coding too. Computers are stupid. Computers are dumb, they don't know anything. They only know exactly what you tell them to do. I actually have anyone ever heard of that peanut butter and jelly?
Yeah.
Oh, I used to do that, it was so much fun. They'd have to write instructions on how to make a peanut butter and jelly sandwich, and then I always do it first. I was like, all right, give me your instructions, let's do it. And I would find a way to mess it up. You know? I'm like, oh, you didn't say to open the jar. I thought you were supposed to put the peanut butter on the bread. So it's really, you gotta be really specific. Okay, so that's my code to make a polygon. And here's some different things that we can add. So this is something I would say too, okay? You guys might notice in my example code, there's a lot of comments. And what's the purpose of a comment? This is something we wanna tell students. Like, why do we put them there? So here, you guys are new, suppose you've never done any coding, or you haven't read my code, because even if you've coded before, when you get into really long, complicated programs, I don't know what that does. And so we add comments, and in Python, we add comments by putting a hashtag, or if you know what they're supposed to be called, it's a pound sign, right? So I would say this shows all the commands in PyGGB, okay? And then here I can say this creates 4 points, right? And then I can say this creates a polygon. Cool. All right, now, I don't like that we can see these points though. I don't want the points there, I just want the square. Okay, so there is something that we can do, and there's 2 ways to do it, so I'll show both ways. You can add parameters to the point function to make that not visible. So I can say here, after 0, 0, I put a comma, is, oh, not capital, so is, why is it doing that? Equals false. Okay, and let me run this. Let me switch this order back. And notice how that 1 point is no longer visible. See that? Now another way you could do it, suppose you already created the point and you're like, oh man, I didn't want them to see that. You could also put b dot is visible on the next line because that point is named b equals false. Now b is no longer visible. So both ways work, depending on how you want to do it. All right, who's with me? Good? Who's lost? Okay.
I got lost a long time.
Oh,
I couldn't even find the words on the bottom.
Alright, so let's see. Okay, you're typing it though. Here, hit run.
Yeah, I was thinking about it. space between the points.
No.
She's got a comma.
Wait. I'm a little confused at why this isn't working, because it should. Here, try opening it up here.
So I never get the comma.
Oh, here. So now I'm saying line 7. There's an error. Oh, you put a point instead of a comma. Alright, so one thing, and actually, so it is a good idea to do in another window, because I'm just going to demonstrate what you just did. Thank you for volunteering to let me show. So she accidentally put a point here. And this is actually a really big thing in coding. Like, you make these errors.
What did you do?
Who can see my errors?
Dot.
Okay, but you saw me do it. That's cheating. Okay, but yeah, there's a point there instead of a comma. I honestly I didn't see it, right? So we ran the code, and we can see here the console log. This tells me what line my error is in. It's an incredibly valuable tool, because without that, I probably would have taken a lot longer. But I can see, okay, line 8 has an issue.
And you went to a different window.
Yeah, I opened it in a new window. Yeah. And then I can say, oh, I put a point there. And now it's working, right? Hopefully? Okay. So, yeah, so I would definitely open a new Python window for each one rather than doing it in the embedded book, just so you could see everything.
And I did get the crisscross applesauce that you were talking about earlier, but I don't remember what you said.
So it basically reads them in counterclockwise order. So if you look at where you put the points, 0, 0, 4, 4, 4, 0, 4, 4, that, it's going to go in that same order, just like you would teach in math. When you name a shape, you name it in counterclockwise order. So if I were to switch this and I said, you know, CB, it's going to do that again. And we don't want that, so we're going to do, so if you guys didn't already, go ahead and make all your points invisible, however way you want to do it. You can actually even do it this way too. That's a third way to do it. I'm gonna make sure that works before I say that. Oh, never mind, it doesn't work that way. It does for some stuff, which that's something that I brought up too when I was talking to Ben. All objects should have the same functionality, you know, for certain things. Like color, which we're going to learn about how to change colors too, and opacity, things like that. So changing the color of the square. So here, there's also an option for color. And if you guys remember how we did that, so I can say polygon, comma, color equals, what color do you guys want me to make it? Blue? Okay, so that would be RGB, so it would be hashtag 00F, I believe.
So the color is only hex?
So you can do hex, there is an RGB way too. Okay. So you can make like a list, it has to be between 0 and 1 for each of them, and I have that example on like the last page. Sometimes I forget the syntax, but basically what I do when I forget the syntax is I keep doing it and read the error messages. And it usually tells me how to fix it.
Okay, so how did you change the color?
So if you see here, I added a comma and I said color equals, and I decided to use hex because I only have to do 3 characters. You could also do it with 6 characters if you want to get more specific with the color. But basically, so it's always RGB. So I did red 0, green 0, and then F is the highest. So I said blue F. And if I wanted to make it purple, I can make, all right, let me change red to F. And then now, oh wait, it's kind of pink, so maybe I need a little bit less red, right? So somewhere, instead of using full red, let's use half red. So let's say 8, whatever. It goes from 0 to 9, A to F. Yeah. Because, so basically, so basically in hex is yes, yeah, it goes up to 16. So that means that, and they use basically symbols for when there's no digits. So after 9, there's no symbol for 10, so they use A. And then B is 11, and does that make sense?
Yes.
All right, and then so now it's more purple. So that's a fun little thing. And that would be like, honestly, colors in that would be a whole lesson in itself. Like, so how do we get this, like, where do we, I just have been doing it so long that I know already, but I wouldn't expect a student to just know that. I would probably say, hey, you want a certain color? Hey, let's Google pink in hex. And then they can go here, all right, pink in hex. And then let's take that, put it right here. And this is a 6 digit, so you can either do 3 or 6 in hex. Not in between, you can't do 5, it has to be, basically what you're doing is saying that the 2 spots allotted for red is the same, so that's when you do 3. And you can hardly see that, so I probably would have picked that color pink, but you can see kind of how that works there. All right, what questions do we have before I go on to the next thing? Yeah.
Have cut, paste, or undo, or things like that while you're.
So in the code here,
Like if you wanted, oh, it's too light, let me undo what I just did.
yeah, so I just said Control Z, Control Z. So just like in the text editor, yeah. Good question. I actually had to test it to find out. But yeah, so I didn't like that color. I just, basically, you guys, it's the same as you would do undo on your keyboard. Control Z is the same on PC?
It is.
Yeah, okay. All right. Cool. All right, so now, I noticed here, I repeated some stuff, right? I made 4 points, and I, you know, based on their position, is there any way that I can make this simpler? Like, rather than writing 4 points, can I let the program know that I'm repeating an action? So it gets a little complicated here, right? Because they're not completely the same. So that's where we go into part 2. And I do have some info here. So like, if I draw a square, or I guess first I should look, this is the syntax in Python on how to do a loop. So it's for I in range n, print I. You guys can actually even, let's go into our code here. I'm gonna copy this. And, you know, I'll just put it right here, just so we can see what happens. And I broke something. What did I do? Line 6. All right. Python is very picky with indentation. If you are not perfect indentation, it does not work. And n is not a number, so give me a number. 5. Okay. So now it prints the numbers. If you look here, 0 through 4. So when I say for I in range 5, it's going to say, okay, it goes from 0 to 1 less than that number. What questions do we have about this? Because I know I kind of jumped in there. And the output is right here together. So 0, 1, 2, 3, 4. And here I did for I in range 5. So if I wanted to print numbers from 0 to 10, what would I do? Yep. We have to go to 11 because it always goes to 1 last. Now if I wanted to go, I don't want to start at 0, I want to start from 1, right? I can do that too. I just basically say, okay, here's my starting number and here's my ending number. So I would say instead of for I in range 11, for I in range 1, 11. And if you look here, it goes from 1 to 10. Right. And one thing too about this is that I that I used right here, that doesn't need to be an I. I get to decide what that is. If I want to say for Sam, because that's my name and I'm obsessed with myself, I could say Sam, and then here I just got to make sure that it matches. Okay? And it's going to use that. So that variable is interchangeable. So if I'm using it to say represent a point, I can say for point in range. And I would suggest that to a student. Don't use your name. Your name doesn't tell me anything about what's going on here. Use descriptive variables. Okay? Because later, you're going to have to look at this and figure out what you did. And I promise, you're going to have trouble explaining your own code once you start getting into more complicated stuff. Unless you're using descriptive names. All right, so we talked about loops, right? What actions in a square, because you can use it to just print something, but you can also it to repeat an action. So what action did we repeat when we made that square? Points, right, the points. Okay? And if you look here, so I can let you guys try to think of how you do this, because if you notice the points, but they're all a little bit different. They're using the numbers 0 and 4. So making a loop with this is a little bit complicated. If we had more time, because you guys are my students. I'm teaching coding. I do not teach how to create the polygon and how to do a loop in the same session. I just don't. It doesn't make sense. They are grasping this, they're digesting it. If I tried to do both at the same time, they wouldn't finish. Okay? And that's just how it is. So you don't want to go too fast, but since we're here and I want you to see the progression of how I would do this, I would do, here's activity A today. Okay, tomorrow. All right, look what you did yesterday. Now, do it with a loop. Okay? So, there's 2 ways that I did this, and you guys could try to do it here if you want, but I also put a sample code here that was square loops. Let me open that up. All right, and I did it in 2 different ways. So the first one, I used another command that I didn't talk to you guys about. Here, I created a list. You know what, I'll do it with you guys. All right, so where's my blank one? All right. All right, so let's do import GeoGebra. I'm creating a list, so I just decided to call it point list. Okay, this is going to store all the points I'm going to put to make my square. Okay, and I find it easier because there's 2 ways to do this. You can do 2 nested loops, which is a bit more complicated in my opinion, or you can use the rotate command because we all rotate when we're creating a square the same amount around a given point. It's a lot easier to write that code than it would be to try to figure out, okay, what's repeated here. If I say, how much did I rotate around the center this time, then I can multiply by that for the second point. Okay, like so 0 times, 1 time, 2 times, 3 times. And so let's start with that. So I'm going to start with my center point. So I'm going to say center equals 0.00, right? There's my center. All right, and can I make this bigger? How can I? All right, I'm gonna have to ask about why this is not. I really want to make more space here, but I don't know what's happening. Okay. All right. Oh, you know what? Here. That's fine. All right, so I don't want to. Can you guys still read that? All right. So there. So now I'm gonna do my loop. This is the fun part. All right. So I'm going to do a lowercase p for point here. Anyone have any ideas why I'm using a lowercase p and not a capital P?
I was just about to ask that because I tried running it before, but I got an error message because I didn't use capitals for center and point.
Yeah. So you have to be consistent. So Python is case sensitive. So if I use a lowercase p, that means every time I'm referring to that, I have to use a lowercase p. So why do you think I use a lowercase p instead of capital?
Capital is command.
Exactly. The capital is a command. So the program doesn't know, are you talking about the point command, or are you talking about your variable point? Right? And that's actually, I've had people who've been coding for years make this mistake and not know why. What's going on? Why isn't this working? I'm like, yeah, you know, after 5 people look at it, we're like, oh, you use the same name. Okay? So for point and range, there's 4 sides in a polygon, right? And then I'm going to say, let's see, D, all right, this is going to be a temporary point, so I'll just call it temp
What is it?
equals. So range is basically saying how many times you're going to do it. So this is going to go from 0 to 3, which is still 4 repetitions. I actually don't really care too much about the number as long as it happens 4 times. Actually, I do care about it in this case. Let me explain why. So I'm going to say rotate. And then my name is, I'm rotating center. Oh, actually I need another point. Let's say point 4, 4, right? This is the point I'm rotating. Yes?
Samantha,
Because this point isn't it's gonna be replaced each time I run the loop.
Oh,
Yeah. Alright, so I'm gonna say rotate point 44, comma, and then I'm gonna say point times, I actually should put rotate. And then how many degrees are in the corner of a square? 90, right. So I'm gonna do, oh, this one was tricky. Let's do import math. Math.pi. So basically this is in radians. Now there is a way to do it in degrees, but I haven't tried yet. So we're gonna go stick with radians today using math.pi over 2. That's the same as 90 degrees. Are we good with that? Okay. And if you guys didn't notice, I kind of just snuck this in there. I also did import math at the top. So this is actually another Python library. If you don't import it, it doesn't know what you're talking about. Okay? Alright, so point math.pi over 2, and then about the center. Alright, and I'm just going to run this so you can see what it's doing so far. Because right now, all we did is make the 4 points. So it made the 4 points, but they're just all separate. They're not coming together. But you can see that I did this in 1 line rather than doing it, or actually I guess 2 lines, rather than creating 4 separate points. Cool? Who's with me? Or thumbs up, sideways, down? Yeah? Down?
I've got an error on my line 10. I can't see your code.
Oh, yep, sorry here. Let me zoom out a little bit.
Probably the comma center.
Oh, math.pi.
Yes. So that is a, yeah.
Is that beneficial? Somebody
Maybe the lines, the colors.
So that is a great question. So is that beneficial to do it in less lines? And I would say when you're learning, it's easier if it's more. But once let's assume that your student, they might be in 7th grade right now learning this, right? But then they go on to become a master coder writing for Microsoft or something like that. And when they get there, it's called abstraction. Basically making it so it's a simplified version, easy to read, so you would have comments to explain what's being done. But if you can somehow take something that would have been 5 lines and putting it in 1, it's going to make things easier. And once we get to functions, that's also going to be another way to create an abstraction in your code where, instead of making a loop, you can actually make a function called draw square. And then the person reading that code later knows, okay, that's what they're doing there. Which is what you would do after loops. You would do, okay, now let's make a function. Does that answer your question?
I think just in terms of like the computing power of computers, it's like if I use too many lines of code, it's going to slow down if you're reading it.
It also makes it harder to read. So it does once you have a lot more. So suppose I was making, 5 squares, or maybe I was making a 10-sided chain. Would it be, easier to read if I made 10 separate points, or if I made, just a loop that said, and you could see here, oh, we repeated this 4 times. Like you can look at the code and see what it does, and that's the goal. All right, so here, now this is our shape. I don't know why it looks weird there. Okay, but we didn't make a polygon. So in order to do that, we need to add those points to a list. That's why I created a temporary point. And I'm gonna go ahead and make temp.isVisible equal false. And then if you guys remember, I created point list up here. And I gotta remind myself the syntax for, I think it's point list dot append, and then I would say temp. Let me make sure this works before I tell you. Yeah, it did. Okay. So this is basically append means add. Okay. I added this point, which I named temp, to my list. Okay. And it got repeated. It got removed each time. And if I go here, right? Print is a command which is very, very useful for debugging. If you think you created a list with 4 points, but it doesn't turn out that way, you can print so you can see what's in that list. So if you look here, oh, no, I printed temp. I need to print point list. Let's see. it should be a list with 4 points in it.
So you have to put print within the print.
No, you just put print, here let me zoom in, and then the name of whatever variable you're trying to.
Okay.
Yeah. Now, I have my 4 points, I want to create a polygon with it. How do I do that? Polygon. And we use that list because right now it's already a list. We don't need to add anything to it. And then let's hope this works. There we go. All right, so this is coding lesson day 2. You guys did 2 coding lessons in one day. And how much time do we have? All right, we got like 8 minutes. So like I said, I didn't think we would get through the whole thing, but I wanted to share, like, okay, this is actually what I would do with students. Each page of this book would probably be a different day of teaching coding. I would do day 1, basics, like just simple commands. Lists, actually, I take that back. I would not do lists in the same day as I did loops. I would probably, start with loops and then do lists. But with GeoGebra, that would make it easier to make a polygon with. But that list in itself is a whole other concept. So we have to really figure out what's the best way to scaffold this material so the students aren't getting too much in one day. Because as you guys have experienced, just doing 2 of these things was probably a lot, right? Sorry if I did that. But if you go at the right pace and you let them explore, I let people mess up. I try not to help too much because if I do the work for you, the biggest part of coding, the biggest job, is figuring out what the problems were and debugging those solutions. So even that little period, I would have been like, hey, what does your error say? I wouldn't have told them what it was. I probably would have seen it immediately after I looked at the error, but I wouldn't tell them that. I said, what does the bug say? Like, what does it do? And I said, did you ask Joe over here? Like, did he see your error? Like, do you know where that is? And then they're not just learning coding, they're learning debugging, which is way more of the job of any coder than it is to just write it. Because if we're being honest here, as you get into more professional coding, you just copy and paste from places and figure out how to make it work. Like most coders don't write the whole thing from scratch each time. The next thing, which we'll briefly talk about functions. So the next step here, I created this square, and while it might not seem that simple, right, for this particular shape, like it doesn't simplify it that much, imagine I wanted a 10-sided shape, right? So here, let's make this 10 sides, right? And then here, instead of math.pi divided by 2, I would do math.pi divided by, wait, is that right? 5, right? Yeah. And then, same amount of code, 10-sided shape, which before would have required me to do 10 separate points and, and separate commands for that. So this is one of the beauties of a loop, right? I can make a 100-sided shape if I wanted. I guess I could do it, right? This computer is fast enough to handle it. It's gonna look like a circle, but there we go, okay? So it basically makes, I took 100 lines of code just now and put it into, 15, but I added spaces. So a couple notes about Python, because I don't know, I don't have that much more time, so maybe we'll get to functions. A couple things I want to note, if you're not familiar with this language, it is my absolute favorite coding language. I love it, like so much. I can talk about it all day. And I've written in Java, JavaScript, C, all of these languages. But I love Python because it's easy to start with. Students can pick it up because everything's in English. Like there's not, like if you look at JavaScript even, which is one of the simpler ones, like to make a loop, it's like for I less than K, Y, Z, whatever. It's nonsense to most people. But this, for I in range or for point in range, it's not that complicated to understand what's going on. They use the word and instead of a symbol, like just little things. And one thing that's really important though about Python, or I guess versatility, you can import tons of different libraries. So there's other things created by other people, libraries of functions, that you can use in your code. And I've used Python to create robots. I had students use it to control a motor. I've had students use it to make a game in 3D. I've had them, it's just so versatile. I had a student, anyone use Canvas? Yeah? They wrote a Python program to export their assignments from Canvas into a planner that they made. Okay, so it's just the most versatile language that is easy to use that I've ever had. And it can get extremely complicated, or it can be very simple. So it's really what, I would let students kind of, at the end of the year, they would choose a library and a project, and they would make what they wanted to make. And I would help them support it through it, meeting with them one-on-one, and it was really cool what they came up with. The other thing, different than almost every other language. I don't know if you guys saw this, but let me just show you what happens here. If after that list, after this loop, see what I did on line 10? You guys could run it, you're gonna see. It does not like that. So in Python, indentation is everything. If you are not indenting your stuff right, it's not gonna work. So one way that I do that, if I had a mess up, I'll just go back to the previous line and hit return, and it fixes it automatically. But if I did that, and then on the next line I did this, it's not gonna like that either. Like this is what tells the program, the indentation, that's all part of that loop. So if you switch that around, it doesn't know what's in the loop and what's not anymore. And I don't think most other languages are like that. Most of them use a different syntax for that. All right, let's see. All right, I have 2 more minutes, so you guys can feel free to go through the rest of the book. That's why I made it, so you can, at your own pace, email me questions, whatever you want. But what questions we have now? See, Levo? Okay. About any of this.
I have a technical question.
Okay.
Okay, so your 100 polygon just disappeared, but so in line 9, okay, and then in line 10, what are you dividing by to find what angle?
Oh, okay, so basically if it's 100 sides, I would divide by half of that. So if I wanted a 7-sided shape, what's half of 7? Yeah.
But, okay, so is that representing
The angle.
which angle?
That's the angle of rotation. So it goes here, it rotates pi over.
So it's the central angle?
Yeah.
Okay.
Alright. Yeah.
How do you stop the 0.44 from being visible?
So I actually, so you would do in here, comma is visible equals false. So notice how, so that's actually a really good question. So this point here, I created within the command, and it's still visible because that's actually another point. It has to create that object before it can rotate it. So if you want it to be invisible, you just have to add that in there, and now it should be.
Yeah, I tried putting the is visible false at the end of that command.
Yeah.
And it didn't work.
So it's because it's like a whole, like basically you would have made the rotation, which I guess technically is like, but yeah. So, or the rotated point became invisible, but the original point here, so that's actually a really good point. Even though I didn't name this with a variable, when I created that point inside of that command, it does create it as its own object. Okay, so before I finish, I do want to share, at the end of this book, there's the closing. There's a spot for feedback, which you guys can share that on your, what did I just do? Okay. Yeah, here we go. So command minus. All right, so here there's feedback. So you guys can go to that and leave any comments. I'm hard as nails, so if you have criticisms, that's fine. You can say good stuff too, if you want to. Documentation. So this is in beta. So there's not a lot of documentation on PyGeoGebra. I know there is this person here, which I might have linked. Oh no, his name's Flo. He's working on the documentation as part of his master's thesis. So when that is available, I will share it with everyone. But right now, this is what we have in progress here. Yeah, here, his Florian Durl finger. And he started a library, but unless I gotta look, I haven't been here in a while, a lot of it is incomplete. It says to be determined. So he's still working on that. This other one is in Spanish, but it is a lot more comprehensive. And you can probably use a built-in translator. I think there's a way to do that. Yeah, translate to English, and you can read some of it in English. But that has a lot more information than the other one. And then last but not least, I have, documentation. My contact info is all here, so you can email me. I'm still stuck on it's called Twitter, so it says Twitter, sorry. Cruz is my maiden name, and I just kept it on my Twitter, so that way it's easy to find. LinkedIn and email. And then Ben Dorth. You guys heard me talk about him before. He's the guy that basically created this, along with other people, but he's like the head honcho on that. So it's still in development. He has his email there. He also has something, I heard somebody was doing Scratch. He's created basically a bridge between Scratch and Python. So that's pretty cool. And you can reach out with him with questions about this or suggestions, because like I was saying, many times it's in beta. There's a lot of stuff that we're working on, or they're working on. I'm not doing it. I'm just using it. So, cool.